Welcome back to the deep dive. So, if you're building with large language models today, you're going to hit this fork in the road, architecturally speaking. LangChain or LangGraph. And look, this isn't just picking a library. It really dictates the shape of your app, right? Is it a straightforward pipeline or something more complex like a thinking system? When you dive into the source material, especially those side-by-side comparison tables they lay out, it gets pretty clear this isn't some kind of rivalry. It's more like stages. So our mission today: use that detailed research, use those tables to help you get past the which one headache and see them as different tools for different jobs, different levels of complexity.
Exactly. That's a great way to put it. They're definitely interconnected, these two projects, but they solve different problems fundamentally. LangChain LC, that's your base framework.
Mhm.
Think of it like your toolkit. It gives you the building blocks, document loaders, vector stores, model wrappers, all that stuff. And crucially, it gives you LCEL, the LangChain expression language.
What, the glue?
The glue, yeah. That declarative way to chain things together.
Mhm.
Makes your code readable, makes it run fast. LangGraph, or LG, well, it builds on those LangChain components, but its whole identity is different. It's a graph engine. Specifically for building agents, workflows that need cycles, it treats your app like a state machine, not just a sequence. So if your job is simple input comes in, output goes out, maybe like a basic ROG setup, LC is probably your answer.
Straightforward.
Yeah. But if your application has to have like internal logic, if it needs to plan, act, maybe recover from errors, coordinate different steps, keep track of things over a long conversation, LangGraph becomes pretty much essential.
Okay, let's dig into that. Because the source material has these great comparison tables that really crystallize the differences. This is where the choice should hopefully become clearer. Let's start right at the core model, the fundamental structure. You mentioned LC is built on linear chains. Even with LCEL being powerful, it's essentially step, 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 a pipeline.
Right. Optimized for that linear flow. Speed, less overhead.
But LangGraph, that's a whole different beast. It's a graph, nodes and edges, conditional logic baked in.
And that jump from pipeline to graph, that's huge.
Yeah.
It unlocks complexity the linear chain just wasn't designed for, not cleanly anyway.
Yeah.
Which brings us straight to maybe the biggest differentiator, state.
Ah, yes. State management. This is where I think anyone who's built a slightly complex agent has felt the pain.
Oh, absolutely.
Yeah.
In LangChain memory, state, it's kind of optional. Often it's like an add-on you wrap around a chain. It works, but it can feel a bit bolted on, maybe episodic.
Okay.
LangGraph just flips that completely. It demands
Yeah.
central, persistent, checkpointable state. It's not an option. It's the core. It's the application's memory shared everywhere across all the nodes in your graph.
But why is that specific kind of state, persistent, checkpointable, the deal breaker? Is the complexity of managing a graph worth it just for better memory?
Well, there's definitely a bit more setup involved, you're right. But the payoff, especially in production, it's massive. Think about it. You have a research agent. It's running for, I don't know, an hour. It does 10 web searches, queries 5 databases.
Yeah.
Then step 16 fails.
Right. And with a basic LC setup, you might lose everything. Start over.
Often, yeah. Or at least lose significant context. With LangGraph's checkpointable state, because it saves the state at transitions, you can actually see the failure, go back to the last good checkpoint, maybe tweak something, and restart right from that point.
Okay. So for complex, long-running things where failures will happen.
Exactly. That persistence is reliability in practice. It saves you from having to rerun the whole thing.
And that persistence, I guess, it ties directly into control flow, which is another major split highlighted in those comparisons. LC, being the pipeline, is mostly sequential control.
It is. You compose steps, sure, but loops, retries, branching,
Yeah.
that often means coding it manually inside function, right? Inside a runnable.
Yeah, it can get messy, nested ifs, complicated logic hidden away.
And that's where LangGraph really shines. It offers native loops, branching, retries, even backtracking as part of the graph structure itself. So when your agent needs to, say, search for something, check the result, and if it's not good enough, loop back and search again differently, that's built in. It becomes an explicit edge on the graph.
So instead of burying if retry deep in Python code.
It's right there on the diagram. An edge may be labeled retry or confidence low refined search. It makes the logic visible, much easier to understand, debug, and maintain over time.
Speaking of control and maintenance, what about human in the loop, HITL? That's critical for safety and compliance. The comparison suggests LC handles this, well, ad hoc.
Yeah, you can kind of force a pause in LC, but it often feels like you're working against the grain. LangGraph makes HITL first class,
Meaning?
meaning because it controls that central state, it has built-in capabilities to pause the execution, let a human inspect or even edit the current state, and then resume the process cleanly.
Right. So if your agent is about to, I don't know, send 1,000 emails or spend actual money.
Exactly. Or modify a critical database record. You don't just want human approval. You need a reliable way to enforce it. LangGraph provides that pause, inspect, edit resume capability natively. It's part of the engine.
Got it. Okay, one more technical point before we move to practical decisions. Observability. Both work with LangSmith, which is great for tracing, but LangGraph offers something extra.
It does. Because of that graph structure and the state management, the source material points out it gives you node-level traces. And this sounds fancy, but basically a form of time travel debugging.
Time travel. Okay, unpack that. What does that actually mean when my agent breaks?
It's really the payoff from that checkpointable state we talked about. Since the state is saved or versioned at each step, time travel just means you can load up a trace in LangSmith, see the graph, click on a failed run, and literally step backwards and forwards through the execution.
So you see the exact state inputs, outputs, memory at each node transition.
Precisely. It makes figuring out why an agent went down the wrong path, why it made a bad decision, incredibly easier than trying to piece it together from, scattered log messages. Failures become almost instantly visible.
Okay, that technical breakdown really highlights the architectural DNA of each. But let's pivot now. Let's talk practical application. The developer staring at a new project, needing to make a call quickly. The source provides a kind of quick decision matrix, more like rules of thumb. Let's walk through that. When is LangChain the clear, confident choice?
Right, let's make it concrete.
First signal. You need to prototype RAG for a document set.
Yeah, LC is perfect for this. It's got the loaders, the retrievers, the LLM wrappers. Using LCEL, you can string together that retrieve format invoke output sequence really cleanly, really fast. No need for a complex state machine for a single Q&A pass.
Makes sense. Second signal. Simple tool use, maybe just 1 or 2 API calls.
Again, classic LangChain agents territory. The agent might need to decide, should I use the search tool or the calculator tool? But it's usually a short process, maybe one decision. LC handles that, handles the structured output for the tool calls nicely, and those runnables make it easy to swap things later.
And the third signal, your main goal right now is just vendor swapping, trying different models or vector stores.
Exactly. LC's biggest strength might be its huge ecosystem of integrations. Because you want to switch from OpenAI to Anthropic or Pinecone to ChromeDB, LangChain likely has the wrappers ready to go. Keeps your core logic stable while you swap out the components. It acts like a standardization layer.
Okay, so those are strong signals for LC. Now, flip side. When does the complexity graph in LangGraph become not just nice to have, but necessary?
It becomes necessary when the application stops being a simple function call and starts becoming more like a service, something that needs memory and resilience. Signal 1. You're building a multi-turn support workflow.
Like a chatbot that needs to remember the conversation?
Exactly. If a user asks a question, gets an answer, then asks us follow-up 5 minutes later that refers back to the start. You need that persistent state. And if that workflow involves, say, fetching data, checking if it's good, and retrying the fetch with different parameters if it's not, that requires LG's native loops and state management across multiple turns.
Okay. Signal 2 for LG. Building a research assistant that plans, searches, and verifies.
Ah, the classic agentic loop. This is really the core use case where LG shines. A linear chain just fundamentally struggles here because the outcome of a step, like a search, needs to directly influence the next decision. Refine search. Try a different approach. Stop.
It needs to think, basically.
It needs to think, evaluate, and potentially loop back. That iterative self-correction, maybe even simulating an internal debate, that's what LG's graph structure, its loops and conditional edges, models so well, makes it much more reliable.
And the final LG signal we already touched on, human approvals on risky actions.
Yep. If you need that guaranteed pause, inspect, resume capability for compliance or safety, the native HITL support in LangGraph makes it the only practical choice.
So, boiling it down, like the source says, single path, simple job. LC. App needs to decide, act, evaluate, loop. Remember, until it's done, you need LG.
That's the core distinction right there.
This leads nicely into thinking about how apps evolve, right? The idea of application maturity. You might start simple, maybe what the source calls a single tool starter, where LangChain is absolutely the right fit, but then requirements grow. You need a 2-tool upgrade, or eventually even a full multi-agent system. Let's trace that. That moment you go from one tool to needing the agent to choose between two tools, say, searching the web versus querying a database.
Why does that often force a move to LG? Can't you just put a router in an LC chain?
You could try, but it gets complicated fast because the choice itself changes everything that comes after. If it picks the database, the data format is different, the verification needed is different compared to if it picked the web search. The downstream path diverges significantly based on the choice.
Exactly. You really need separate paths, separate nodes for handling those different outcomes, planning, acting, verifying based on the choice made, and managing that divergence cleanly while keeping track of what happened. That requires the state and graph structure of LG. A simple router in LC doesn't give you that same level of explicit control and state management for complex branching. You've basically hit the complexity ceiling of a linear model.
Which leads us to the peak complexity, the multi-agent system, where you have like specialized agents, a researcher, a coder, a reviewer collaborating.
Yes. And this is where LangGraph becomes the coordinator, the conductor. You might have a main router node that assigns a task. The researcher agent, which could be an LC chain internally, runs in its node, does its work, and crucially writes its findings into the shared state.
Okay, so the state is the handover mechanism.
It's the shared blackboard. The coder agent's node activates, reads the research artifact from the state, generates code, writes that back to the state. Maybe a reviewer agent node then checks the code.
And it loops until some condition is met, like the reviewer approves.
Precisely. And notice the blend. You're using LangGraph for the high-level orchestration, the state management, the looping logic. But inside each node, you might well be using optimized LangChain components, specific retrievers, chains, tool calls. LG manages the team. LC components do the individual tasks.
That also loops back beautifully to the idea of guardrails and compliance. That central explicit state in LG makes implementing guardrails much more robust, doesn't it?
Absolutely. It shifts guardrails from being just, a policy document somewhere to being actual visible parts of your code, parts of the graph.
Like an explicit node.
Exactly. If the rule is human must approve database rights, you literally add a human review node right before the database write node. The graph execution must pause there. It gives you real operational control. You can point to the graph and show auditors, look, the process halts here for review. You can inspect the state, maybe correct the planned database query if needed, and then explicitly resume. That level of built-in accountability is huge for serious production systems.
So wrapping this all up, what's the main message for someone listening, trying to make this architectural choice for their next project? It really feels like the core takeaway is this isn't about which tool is better. It's about matching the tool to the shape of your problem, both today and maybe where you see it going in, say, the next 3 to 6 months.
Couldn't agree more. The choice becomes clearer then. Need linear processing, speed, simple RA, basic tool use. Start with LangChain. Its simplicity is a strength there. But does the application need to think complexly, loop, retry, maintain memory over long interactions, require human checkpoints? Then the investment in LangGraph structure pays off. Its ability to manage state and complex control flow is what you need. And remember, it's not necessarily either forever. You'll likely use both. LC components powering the actions within LG nodes orchestrated by the graph.
Which brings us perfectly to a final thought, a practical challenge for you, the listener, inspired directly by the source material. Don't just take our analysis as gospel. Try it. Pick a task from your backlog. Something valuable, but maybe a bit more complex than a single query. First, build it out quickly using clean LangChain, LCEL, maybe one tool. Get version 1 shipped.
Then, as you inevitably find yourself needing planning steps, needing retries when a tool fails, needing that human approval gate, take that same core logic and refactor it. Migrate it into a small LangGraph, maybe just 3 or 4 nodes, with a proper shared state object.
And here's the key. Measure it.
Yes, measure the difference. How long does it take to get a reliable answer? What's the failure rate? How easy is it to debug when things go wrong? Comparing those two implementations side by side, that will give you real numbers, not just opinions, on when the structure and, yes, the initial overhead of LangGraph truly earns its keep in your specific context.
A fantastic practical way to solidify the concepts. Thanks for breaking that down.
My pleasure. It's a crucial decision.